Example 1 is graph each parabola, identify the vertex. So remember, for the vertex, you do opposite b over 2a. That's your x value, and then you plug in your y value. You plug in your x value to get y. The y-intercept, so to find the y-intercept, let x be 0, and the axis of symmetry. So that's going to be x equals whatever your vertex value is. So make a table of values. So what you're going to do is, first step is always find the vertex. So I have this parabola. So just looking at this parabola, I know that it opens up because the number in front of x squared is positive. And I also know that it's narrower because this number is farther away from the absolute value of 1. And then I know that the y-intercept is -5 because there's no b term, and so c is the constant, and c is where it crosses the y-axis. So first I'm going to find the vertex. So I'm going to do opposite b over 2a. So I do opposite 0, because it's not a b, over 2 times 3, which is 0, -5. So my vertex is at 0, -5, and I know it opens up. And then what I'm going to do is make a table of values. So I'm going to put in, I always put my vertex in the middle. So 0, -5 in the middle, I'm going to pick a negative, I'm going to pick a positive. So it's going to be -5 plus 3 times -1 squared. So -1 squared is 1, 1 times 3 is 3, this is going to be -2. And then this is going to be a -2, just because you have the whole symmetry going on with the parabola. So if this is my vertex, I can mark at 1, -2, and -1, -2, and I know it's going to open up. And I should do a better job than that, but make it curvy. Make sure you have arrows at the end. And you could add another point too, but just for time, I'm just going to do 3 points. I think 5 points is better. And then my vertex is right here. My axis of symmetry is the equation x equals 0. And my y-intercept is 0, -5. So for the second one over here, we can just talk about this graph, what it looks like. It's going to open up because this is positive. It's going to be narrower, and the y-intercept is -4. So I'm going to find the vertex by doing opposite b over 2a. So it's 0, plug in 0, and you get -4. And so right here, and then you put 0, -4 in the middle, peg it at -1 and 1, and plug it in, and you're going to get -2 and -2. And then you make your parabola. So the vertex is here, the y-intercept is also right here, so the y-intercept is 0, -4, and the equation for the axis of symmetry is x equals 0, because it crosses through at 0. This chart right here gives a breakdown of graphs, of how to graph a quadratic. So I already mentioned in how to graph them before about when to know if it opens up or down, but this chart really shows you that if a is greater than 0, it opens up. So if it opens up, it's going to have a minimum. And if a is less than 0, it opens down and it's going to have a max. And we've already discussed that the axis of symmetry is a line, x equals -b over 2a, and how to get the vertex. And then the y-intercept is plug in x is 0 to see what c is. But if it's in standard form, you can see what the y-intercept is. So what is important is when you're graphing parabolas is you can always use this axis of symmetry to find the other points on the parabola. So if you know this blue point and you know the axis of symmetry, you could go right across equal distance to find this point. Okay, I'm going to do a couple more graphs. So these don't have, or they have b terms. So just to talk about what this looks like, this is going to be opening down. The y-intercept is going to be 2. And this time I'm going to have a b term, so I'm going to have to do the vertex is opposite b over 2a. So it's negative 4 over 2 times negative 1, so it's 2. Now to find the vertex, you need to plug 2 back in here. So it's going to be 2 squared is 4. The opposite of that's negative 4. Negative 4 plus 8 is 4. 4 plus 2 is 6. So this vertex is going to be at 2, 6. So I'm going to go over 2, up 6. And then what you do is, if I know that the y-intercept is 2, and right here is, it's not right on the line, but this is my axis of symmetry, x equals 2. I can use symmetry to find what the other point is on this. So if this is 2 over, this is 2 over, and now I can finish up my parabola without really making a table. So let's try another one over here. So I'm going to do negative b over 2a. So it's opposite 2 over 2 times negative 1/3. So these twos will cancel out, and you're dividing by negative 1/3, which means you're multiplying by negative 3. So the vertex is at negative 3. So now I'm going to plug negative 3 in. So it's negative 1/3, parentheses, negative 3 squared minus 2 times negative 3 minus 3. So it's 9, this is 9, negative 1/3 times 9 is negative 3, plus 6 minus 3. So it's going to be 0. So my vertex is at negative 3, 0. And then my y-intercept is at negative 3, right here. So if my axis of symmetry is x equals negative 3, and I have 2 points right here, I know my vertex and this point, I can create another point that's over here, because it's equal distance, and have this open down, and it's a little more wide. So that's how you can graph it using symmetry. Okay, and then the word problem. A company knows that negative 2.5p plus 500 models the number it sells per month of a certain make of unicycle, where the price can be as low as 70 or as high as 120. Revenue from sales is the product, that means multiply, of the price and the number it's sold. What price will maximize the revenue? So the key right here is revenue from sales is the product of the price and the number sold. This is the number sold. This reads models the number it sells per month. So if P is the price, the equation is going to be P times negative 2.5p plus 500. So to find the maximum, that's what maximize means. This right here is going to be a quadratic. Oops, this equals. So the quadratic in standard form is going to be negative 2.5p squared plus 500p. So we know that this quadratic opens down. We know the y-intercept is 0, so it looks something like this. And I only did the first quadrant because we're talking about positives here. So if it's asking in the maximum or maximize, maximize should key you in that it's a vertex. So what you're going to do is you're going to find the vertex. So you're going to find the x value, which is the p value. So you're going to do opposite b over 2a. So opposite 500 over 2 times negative 2.5. So it's going to be negative 500 divided by negative 5. So P, the price, is $100. That's answering this part. So the price that will maximize the revenue is $100. So you want to set the price at $100. Now, the price can be set as low as 70 or 120, so that makes sense. It fits into the range. So what is the maximum revenue? What you're going to do is you're going to plug 100 in for P. So you do 100 squared times 2.5, or negative 2.5, and then you're going to add that to plus 500p. So the answer is, the maximum revenue that you're going to make is $25,000. So this isn't a business example where it's really important to know the price that you should set on a product. Same with down here. The number of widgets the widget company sells can be modeled by negative 5p plus 100p, where p is the price of the widget. What price will maximize the revenue? So again, it's going to be price times the number that you sell is equal to the revenue. So this is going to be a quadratic again, so it's going to be negative 5p squared plus 100p equals r. And you're going to want to do what's the maximum price. So it's going to look like a quadratic function. This is going to be your maximum. You have to do the vertex. So you do opposite b over 2a, which is opposite of 100 over 2 times negative 5. So that's going to be 10. So the price that you should set on the widget is $10. And then the revenue, you're going to plug in $10 for p. So it's negative 5 times 10 squared plus 100 times 10. So this answer is $500.